This is Eric, KJ4YZI, with another video review / tutorial on a new device I just added to my amateur radio collection. I've always wanted an antenna analyzer because I build a lot of homebrew antennas, and it really helps to have an antenna analyzer to show you where you need to tune your antenna and what it's actually doing. So in this video I'm going to show you what this device is, how to install it, and what it looks like when you're using the software, as well as how to pair it with your Bluetooth smartphone, Android, or Android tablet. This device works either USB to the computer or wireless over Bluetooth to your device. So let's get started. This is the HF Vector Analyzer by Lisic, model ATS 3505B11. Okay, so when you first get your product, it's going to come in a case like this, nice zipper case to protect your device when you're not using it. Hold all your goodies in there. When you open it up, first thing you'll see in here is the CD. The CD contains your USB drivers for Windows, your manual for the device, and your Android application that you'll put on your tablet or your smartphone, and I'll show you that in a minute, so that you can connect this device wirelessly over Bluetooth to an Android smartphone or tablet. We'll show you that in a second, what's on this CD. You're going to get your Lisic HF analyzer. Now, this device right here connects either USB to your computer or, as I just mentioned, Bluetooth to a smartphone or a tablet. On the first side, you'll see we have two ports here. These are two BNC ports, and if you're wondering how am I going to connect my coax to that, well, the device comes with two of these adapters, which are BNC to SO239, and it goes right on the device like this. That way you can connect your coax right to it. Okay, it comes with two of them. For this demonstration I'm going to show you with just one because I'm only testing antenna, but you would need two of them because you can connect the other one over here and test coax cable from one port to the other. If you look in the middle there, it says cable. That's so you can test your coax that's going to your antenna, or if you made a patch cable and you're not sure if it's right, you can connect it across here and the software will show you if it's okay. You'll also see here's the power button on this side, the red power button. If you push that, you'll hear a beep. That means it's on. You'll see the red power light indicating the power is on. If you hold the button again, it'll turn off. On the other side, you'll have your USB connector here. You'll have a charging light right next to it. Now, this charging light is backwards. When you plug this device in to charge it for the first time, or any time, it's going to come up green when it's charging. That means it's not fully charged. When it's done charging, it's going to turn red, so it's backwards. My advice to you, because of the internal lithium-ion battery, is to go ahead and put it on charge when you first get it. Wait till it's fully charged before you start using it. The light will turn green when you plug it in, indicating it's charging, and red when it's finished. You'll also have your MAC address here. This sticker is the MAC address exclusive to this device. So you're going to keep this number handy because later in the video I'll show you how to pair it to your Android device, and it's going to ask you for this number. This is the number for your device to pair it with your Android. Okay, so you'll also receive the USB data cable. Now in the manual it does not say about this cable on why it has two USB plugs on the end. Of course, this end goes into your Lisic. The other end has two USBs, a red and a black. Now the red is intended for only charging the device. It has no software interface on the red port. The black port is so that you can connect it to your computer and use the software. It will charge over the black port as far as I know. But if you just want to charge the device, you can use it with the red plug. You don't need to plug both of them in at the same time. So let's go into what's on the CD and how to install the drivers for your device.
Okay, so the first thing we have to do before we get started is put the CD that came with your HF analyzer in your CD-ROM drive and give it a few seconds. It may pop up with a box here depending on your computer and operating system. It may pop up with a box and say, would you like to open the folder and view the files on this disk? You can click that, or you can go down here to Start, go to computer, and here is your DVD or CD drive. Double click this and it'll show you what's on the disk. Now, before we plug this in, what you're going to want to do is know what these are. Well, the first two folders here are your drivers for USB connectivity between your HF analyzer and your computer. If you have a 32-bit version of Windows or a 64-bit, these are your folders here. These should work for Windows XP, Windows Vista, Windows 7, maybe Windows 8, 32-bit or 64-bit. When you plug your device in, it's going to pop up down here in the bottom and it's going to say something like installing device drivers, and it's going to start spinning and spinning. Eventually it's not going to find the drivers. It's going to say, would you like to point to a location where your drivers are? You click yes and point to this folder on your CD drive pertaining to your version of Windows. So if you have a 64-bit, you're going to point to this folder and it's going to find the drivers in here and go ahead and install them automatically for you. You can also go down here to start, and in the search bar type in device manager. It's going to open your device manager and it should have a section here that says unknown devices or other devices with a little yellow exclamation point. You can right click on that and choose update driver software or update device driver. And when you click that, it'll ask you where are the drivers. They're right here on the disk. So this is given that you have some sort of knowledge on installing drivers for a foreign device or a device that doesn't come with a self-installation executable file. It's pretty simple, and if you can't figure it out, send me a comment on my page and I'll see if I can help you out. We also have the instruction manual here. Now, this is written in English, however, it's sort of hard to understand at some points, and the purpose of this video is to clear this up and show you exactly what this device does and what it means, and will be more in-depth than this manual, but this manual will show you the product data sheet, the specifications, and what it does and the functions. But this video should explain everything without you having to read this, but it's always encouraged to read this first. Here is your Android.apk. This is the Android app for your smartphone or tablet, which I'll show you about using in a minute. But first, this is the app for that. So the easiest way to install this is to go ahead and send yourself an email with this as an attachment. So for instance, if you were sending somebody a picture, you would put their email address in and click attach file, and you would attach a picture. If you send yourself an email at your email address and attach this file, then you go on your smartphone or your Android tablet and you open your email and you'll see the email you sent to yourself with this as an attachment, and all you do is click this in the email and it will come up on your Android and say, would you like to install this app automatically? And you click yes and it does it for you. Then you'll have this app on your home screen on your Android device. You can also drag this file to the desktop and then place this file on your memory card and then plug the memory card into your device and install it that way. But the easiest way would be to email this yourself and then open your email on your smartphone or Android tablet, and you would just click the application here and it would install. This is your Windows software here. This is what you would run for the software, and there's no installation for this. All you have to do is go ahead and drag this file to the desktop like this, and it'll make an icon. There's your your software right here. You don't have to install it. Okay. When you pair this with Bluetooth, normally Bluetooth devices for Android phones or Android tablets, their pairing code is 0000. In this case, the pairing code is 1234. So if you need that, it's on the CD here. We'll get to that in a minute when we pair it. So these are the contents on your CD, and go ahead and install your USB device now if you'd like, and we can move on to the next step. Okay, so you have the USB drivers installed. You're ready to fire up the software. You have your HF analyzer plugged in and turned on. Double click this icon. This is the icon we pulled off the CD before. This is your program. Go ahead and double click this, and there's your software. You can tell the USB device is connected with the blinking red light up here in the top left. That means you have a link, and you can see some numbers moving here, so we know it's doing something. Okay, this video is going to show you the software in action and give you a brief overview of what these mean, but it's a whole nother video on showing you how to tune your antenna. So I'm going to show you what the software will do and what it will tell you, but this video will not help you tune your antenna. This is based on my antenna. I have a homemade off-center fed dipole with a 4-to-1 balun on my tower. So the tests I'm about to show you are running with the antenna analyzer directly connected to the coax, not using a tuner. And let me show you what these things are here. First, on the top left here, you have a Smith chart. Smith chart is very, very important on calculating impedance of an antenna network. I know enough about a Smith chart to know what it means and how it works, but I'm not going to get into that in the video. This Smith chart is based on 50 ohms, with 50 ohms being this center point right here. This blue triangle is representing your impedance on the Smith chart at this frequency up top here with the cable length. So if you were to use the Smith chart, right now it's telling me I have a 1.9, roughly 2.0, 2-to-1 SWR at this frequency with a 32 ohm impedance. So to learn more about the Smith chart, go on YouTube or Google and you'll see what a real Smith chart looks like with a lot more lines than this, and they'll tell you how it works, and it's very interesting. Down here you have the meter. It looks like a speedometer. This is in case you use this device as a micro power meter. Now the scale on this is negative 90 dBm to plus 15 dBm. That's not a lot of power, and I'm warning you, do not connect your antenna analyzer directly to your HF radio and transmit. You will destroy the device. This is used to measure power from your radio through an attenuator first. And if you can look up dBm also online and see what this is based on, 1 milliwatt power levels. I think plus 15 dBm would be somewhere around 32 milliwatts if I'm not mistaken, and that's not a lot of power. So if you transmit directly into this, you will burn up the device. So read more about using dBm for power measurement first before you get into this. I will not be demonstrating this part on the video because I'm not measuring power. Down here you can also, when you're doing power measurements, you can calibrate the dial here for a more accurate reading. These three charts over here, these are three different independent measurements on this software for SWR and reflected power at a given frequency. There's three check boxes here to enable all three of these. Right now for demonstrations, I'm going to only check the first box to demonstrate what it does. Now with this box being checked, this is the only sweep that it's going to make, and the megahertz up here and the megahertz on the end over here are your start to finish. So for instance, for 20 meters we will put in 14.0 megahertz, so 14.350. That's the entire 20 meter band. And when I put those values in, I'm going to go down here and click submit and start continuous scan, and it's going to run a scan from 14 to 14.350 and show me my SWR and reflected power. It's going to run a continuous scan as you see the red bars going across. It's going to keep scanning until you shut the program down or make a change. It'll automatically draw a line here and show you your lowest SWR on this chart here. So right now my lowest SWR is 1.7 to 1 at 14.012 megahertz. That's way on the bottom of the band. Now again, I'm using an off-center fed dipole, so the people that know what this means, I use a tuner with this antenna for multi-band use, so that's why I'm not flat on 20 meters. If you have a quarter wave or a half wave dipole and you type in these frequencies, you're probably going to see a dip go down like this to 0 or 1.1 SWR, then it's going to go back up if your antenna is tuned correctly. That'll show you your lowest point and the resonant frequency. So if it was right here, you would be roughly in the middle of the band. The closer to the bottom, the more perfect your SWR would be. So 1 to 1 would be all the way on the bottom here. And that would be a perfectly tuned antenna with no reflected power. All the way in the top would be a horribly tuned antenna or a shorted antenna with all reflected power coming back to your transceiver. As I move the mouse here on the graph, you can see the numbers down here on the bottom right. F is frequency and VSWR is the number next to it. So if I draw a line and go along the line with the mouse here, I can see what the SWR is as I move up in frequency. So you can pinpoint exactly what the SWR value is at a specific frequency. So let's say you want to do a couple scans. We're going to enable VSWR2, and I'm going to scan the 10 meter band, 28.0 to, we're going to go to 30. Now when you make that change, you're going to want to go down here and click submit and start continuous scan. That's going to add that second chart into the next sweep. Now it's going to scan the first chart, then it's going to scan the second chart. Right now on 10 meters, it looks like my lowest point would be 29.260 in the FM portion of the band at 1.4 SWR, 1.4 to 1. And as we move the mouse here, we can see change in frequency of what the SWR is at the beginning of the band. Now it's going to go alternate back and forth and scan. If we want to enable the third one down here, we click the box and we're going to scan my entire antenna here, or the entire band plan from 1.6, which is 160 meters, all the way to 33, which is the frequency range of this device, 1.6 to 33 megahertz. And I'm going to enable that with the check mark, and I'm going to go down to submit and start continuous scan. And on the third scan, it's going to start this graph down here. Now you'll see 160 meters over here. I am not resonant at all, of course, because my antenna is not set up for that. It's not long enough. But it goes up and down. So my lowest point that I can achieve on my antenna right now is at 3.17 megahertz. That's almost a 1-to-1 down here. And of course we don't talk down there. My highest point besides 160 meters would be right here, almost in the 30 meter band, 9.2, 9.3. It's almost a 10-to-1 SWR, so I'm not resonant there at all. When I use my antenna in this fashion right here, when I use my antenna with a tuner, an external tuner, I can get to tune anywhere I want 1.1 to 1, which is what you want. Perfectly resonant antenna is 1-to-1 SWR, which means all your transmitter power leaving the transmitter is making it out of the antenna. So that's what 1-to-1 SWR means. 1.1 to 1 is about perfect. Now, we're going to disable graph 1 and graph 2 for instructional purposes here, and we're only going to use 3. With this scanning, you'll also see down here the S21 parameter. Now, there's a whole nother thing here with parameters. You can look those up on Google also, but what this shows is you can also test a piece of cable from one end to the other with this antenna analyzer. So you can connect say you made a 3-foot jumper wire and you want to test it and make sure it's good. You can connect it from port 1 to port 2 on the antenna analyzer and run the test, and it will show you on this graph what the cable is testing as. If I tried it the other night with a cable and it was showing me at certain frequencies that I scanned what the loss was or what the gain is on that frequency for the cable. So this is for cable, and being that I don't have a cable connected, it's negative 91 dB, meaning it's not making it from port 1 to port 2 because I don't have nothing connected across. Once you connect the cable from one to the other, these numbers will drastically change, and you'll see up here somewhere, if it's a good cable, the closer to 0, the better. That will mean all your power is transmitted through the cable from one port to the other. So this is what this software will do and what it looks like when it's running. Again, tuning antennas is an art to itself. I've been playing with homemade antennas for years, and a lot of them look ugly, but a lot of them that I've made out of $5 worth of wire have proven to be the best. And this antenna analyzer here will drastically help you in making your own antennas by showing you where you're resonant. There's similar devices out there such as an MFJ 259 antenna analyzer that will only show you as you turn the dial where you're 1.1. It kind of helps to see on a graph here instead of having to go and turn the dial on the MFJ all the way through the band. It'll show you on here what your resonant points are, and if you know how to read dB and you know how to read a Smith chart, it'll be a lot better than just a regular analog antenna analyzer. So this software here is a lifesaver here when you're making your own antennas.
Okay, so you've installed the app for the Lisic on your smartphone or tablet Android device. Now, when you run the app, this is what you're going to see. And remember, I showed you on the analyzer, on the bottom there's a sticker with a MAC address that's exclusive for that device to pair it with a Bluetooth device. So that's the number you're going to enter right in here in this MAC address, is the MAC address that's printed on the bottom of your device. I've already put mine in here. Of course, mine looks different than yours. Put the MAC address in this bar and click link. Now it's going to start running a scan on your connected antenna. And in this case, I'm sweeping from 13 megahertz to 33 megahertz by default. It is using 23 megahertz as the center frequency. Now again, I have an off-center fed dipole, so I have ups and downs and resonant on all different parts of bands. But this is a one-time sweep here, and it will automatically show you, right here, this yellow line, it'll show you at 29.2 megahertz is my lowest SWR at 1.4. So it'll draw a line. If you had just a half-wave dipole on, say, 20 meters, it is going to find the lowest point and put the yellow line right there and tell you up top what the SWR is. Now, you can also slide with your finger. You can slide this bar over and say you want to see what the highest is over here, and it'll tell you at 21.265 megahertz, I'm 6 to 1 SWR at the highest point. And at the lowest point, it already automatically centered on the lowest point. So you can see here, you can go around on your sweep and see what different values for SWR you have on that frequency. Down here, I'm at 26.059 megahertz. I'm 1.7 SWR. Over here, if I drag the line over, right here, at 18 megahertz, I'm 1.5 SWR. So it will also show you up top, it says PIN, which is power in. If you were using this device as a micro power meter, this is where you'd have your power anywhere from negative 90 dBm all the way up to plus 15 dBm. So this is where your power will be displayed, as well as if you're testing a cable from port 1 to port 2, your S21 parameter up here, that's where your reading for that will be. So this is showing you the same stuff as the Windows software, but it's in a more compact form being on your smartphone. It will also show you your Smith chart readings over here with your S11 parameters. It'll show you, if you know about the Smith chart, it will show you that information up here. Now, you can click up top here and set your center frequency to a different value. For instance, if you wanted to sweep from 3 megahertz to 23 megahertz, your center frequency would be 13. So you would type in 13 up here, and that will be the center of this graph. If you wanted to type in your center frequency of 15 megahertz, it's going to sweep from 5 to 25, with 15 being your center. Over here on the right, it shows you your dB over here, and on the left, it will show you your SWR. Across the bottom is the blue line over here, is your S21. Had you have put a cable across both ports, that blue line would be up here in the graph somewhere. You'd be able to see it. Right now, there's nothing connected across both of them, so it's giving me a wide open reading with nothing on the other end. But you'll see that blue line that's on the bottom up here somewhere in a value on the graph if you had the cable connected. So you can test a cable with this on the smartphone app as well as your resonance on your antenna. So this is a handy app to have for this device. in case you're wanting to be a little more portable or just run it from your smartphone or your tablet or you're outside and you want to run it because the device has a battery in it, so you can go wireless with this. Alright guys, so there you have it. I hope this video was informative for you. I hope you learned something from it. My purpose in making these videos is to take all the thousands of hours I've researched on different things and thousands of questions I've asked to people and sum it up in video form to help you out instead of you having to watch 100 videos and come up with an answer for yourself. I have a lot more videos I want to post, working digital modes like PSK31 and others, making your own antenna, tuning your own antenna, and some other stuff. So keep an eye on my channel. You can rate it and post a comment. I can answer some questions if I can. And thanks for watching. Look forward to some more videos from me. 7-3, this is KJ4, Y is the I.